Okay, this is designed to be a quick, all-encompassing piecewise functions video. With these piecewise functions, what you'll see multiple different types of functions. Here we have a parabola, here we have a step function. This looks like a cube root function, but you take just pieces of it in order to be able to still pass the vertical line test at each and every single point and still be a function. Now, first thing we want to be able to do is identify the domain. Now remember, with the domain we are talking about all the x values as it goes across from negative infinity to positive infinity, and what you will see is that there are no gaps. You always have a piece of the function covering it from arrow to arrow. So therefore, for our domain in interval notation, that would be from negative infinity to positive infinity. Set notation, you have the set of all x's such that the x's are an element of all real numbers. So you could write it in either way. Range. The range is supposed to cover all the y values. So as I move along this y-axis again, we are going from negative infinity to positive infinity. Now this one's a little bit different, but because of the arrows and the way that the arrows imply that, hey, we are going to go down and up from the point of 1, we are going to cover all the y values. So this is going to be exactly the same as the domain, where the set of all y's is an element of all real numbers. The only other piece that we want you to do is we want you to be able to identify specific y values. So the function at x equals -3, what is that y value? So you would have to be able to identify -3 and then the appropriate y value at that point. So in this case it would be 0. The function where x is equal to 0. Now notice here you have two different values. Remember, always go by the closed circle, and we identify that appropriate y value. Okay. The function at 2, again, identify with the closed circle. So we have -1, and the function at 4, closed circle, we have 5. So piecewise, you have different pieces of functions put together, still passing a vertical line test, still a function, and we identify specific values based upon the closed circles at that x value. Number 2 is, you see we have an absolute value, another step, and then here we have a piece of a rational function where we approach two different values. Now again, we are going to identify domain and range. Domain along that x-axis, we are going from negative infinity to positive infinity, arrow to arrow, and we cover each and every single x value. So again, we're going with all real numbers. Your choice. You do not have to do both set and interval notation. I'm just writing it out to make sure you guys are staying on top of both. You are able to identify both, but it is up to you which one you would write as your answer. For your range, we're looking at the y values from negative infinity to positive infinity. Now here's where it gets a little bit different than number 1. Okay. Yes, this arrow goes down. It's going to go all the way to negative infinity. So we would have that. But notice it starts approaching at -3. And then from -3 to 1, right here, we are only at each and every single integer. So you would notice we do not have a y value for -1.5 or -0.5 or +3/4. There is no y value there. We only have y values at each and every integer from -3 up to 1. So as we write this, we are going to write it as, and I'm going to do it all as a set notation, all the y's such that your y's are less than or equal to -3. Okay, we can see that right there. We're equal to at -3 and we go down. But then we have y's equal to -2, -1, 0, and 1 to identify just those integers. And actually, we're going to make this y is greater than or equal to 1 to identify that other set where it goes from 1 and up all the way to positive infinity with that arrow. So notice you have basically 3 different sets here with the 3 different functions. With your rational, you're less than -3. With your step, you're just the integers. And then with the absolute value, you are greater than or equal to 1. So you would have to be able to identify each one. Now, the y value as x is -2, so we go to -2, we find where that function is a closed circle, and we can identify the y value as 3. X is -1. Notice we have an open circle, we have a closed circle, always go by closed. X is 1, closed circle open. X is 4, you only have the 1, so we only have the 1. Good, so that's when the function is provided for you. You are given the graph. Can you identify domain? Can you identify range? Can you identify specific values? The next piece we need you to be able to do is to be able to, given the equation, can you give us the picture, identify domain, identify range, and then identify specific values? So this is where it gets a little bit different. So you're going to have to be able to recognize that 3 absolute value of x minus 2 minus 1. So with it being an absolute value, we know that should be a v. That v should be right 2, down 1, and with a vertical stretch of 3. Now, the thing of it is we are recognizing that this function is split right here at x equals 2. So if you need to, we're going to put a dotted line right here to show that, hey, we are going to split the function here. And we also can put the dotted line because it's not equal to. Now as I draw this, right 2, down 1, and I were to go a vertical stretch of 3, I would have my absolute value picture look like this. Now, because we are looking at this where the x's are greater than 2, then I know I only want the piece of this absolute value picture, open circle, going up and to the right where it's positive. We actually don't need the piece to the left. So there is that piece with the absolute value. Now here you have a cube root of x minus 1. Remember that cube root picture from Algebra 2? Looks like that. The x minus 1 is just going to have it move to the right 1, so that's the picture here, where your picture would come up and go through. Now again, we only want the piece where it's less than 2, so that means we would have an open circle, and we only want the piece to the left. And I would erase anything that goes to the right, so that way we can see our two pieces together as one function. So you have your absolute value v, and then you have your cube root. Now notice for our domain, arrow to arrow, everything but the value of 2. So in interval notation, we're going from negative infinity to 2, that union 2 to infinity. Okay. Or you can write it in set notation where x is such that x is an element of all real numbers, but x does not equal 2. And you have it like that. Range, arrow to arrow, encompasses everything. So that one is from negative infinity to positive infinity, or all the y's such that a y is an element of all real numbers. What is the y value when x is 2? That's what f of 2 means. Well, what we understand is that there is no value of 2. That's where it's never equal. So you can either write does not exist or is undefined. Either answer would be acceptable. F of 10. Well, the issue here with the x value of 10 is that it is off our graph. So what we want you to do is we want you to take that 10 and we want you to plug it into both of the constraints. Now, ask yourself the question, this is only going to be true for one, is 10 less than 2 or is 10 greater than 2? So if we're looking at our constraints and we plug that x value in, is 10 greater than 2 or is 10 less than 2? Since it's only true for one and not true for the other one, this is the function you would plug 10 into to be able to figure out that y value. Okay? Since it's not on the picture. So now you would go through the process of being able to simplify 8 times 3 minus 1. And then you have that y value that is not on your graph. Good. So another way to do it, obviously if it's on the graph then it's nice and easy, you just identify it. If it's not, you have to plug it into the constraint, figure out which function it is true for, and then therefore simplify. Okay. Number 4, same idea. Notice again you have another absolute value here. So this is a v. This one is going to be going down. So notice this one is left 3 down, going down. So it's a flip down, and it's also a vertical stretch. So 1, 2, 3, left 3. So I'm going to do this one in red here. Going down, vertical stretch of 2. Now notice we're equal to at negative 2, so we're going to have that closed circle. And we have our picture of our absolute value. Okay. Notice we have here our exponential. The negative is inside the function, so that means we flip over the y-axis. So that means we are going to go up. So 0, 1, negative 1, 2. At negative 2, it's not equal to. So up here we would have our open circle. 1/2 here. 1/4 at positive 2, so again an open circle, and we see that exponential picture, okay, flipped over the y-axis. Last one is our step function. Remember the 1/2, so that is going to be stretched by 2. Now normally we would start right here from 0 to 2, but because we are only greater than or equal to 2, our first actual step is listed here. And we make one extra step. You can continue on. Because you know that each step is a length of 2, so it looks like that. So there's your picture. You have your absolute value, your exponential, your step function. Okay. We'll start with the easy one. That's at f of 2. So f of 2 is going to go by the closed circle. So that's going to be a value of 1. Negative 9, not on the picture, but obviously we can tell that that negative 9 would only be true for less than or equal to negative 2, so we would plug it in to our absolute value function. That's negative 6 becomes a positive 6, so our final answer becomes a negative 12. Good. Domain. So our domain covers all x's as we go across. This one continues on. So we are from negative infinity to positive infinity. Range, a little bit different because you do have the steps, but the steps only will start going into every integer once we are past the y value of 1, 2, 3, 4. So again, kind of like the other one where we had to split it up into 3 different ones, we're going to do that again. So you're going to have the set of all y's such that y is less than or equal to 0. So that's for our absolute value. And then you are going to go that y is going to be greater than 0 but less than 4, and then that y equals 5, 6, and so on and so forth for that set, where it keeps going on and on, 7, 8, 9, but it only identifies the integers, it does not identify the decimals. Okay. Last one, just to show a rational and a log picture. So notice with our rational picture, we'll start with green, that's fine. Plus 3, so that means you are going to have your asymptote at negative 3. So notice we are less than or equal to right here. So 1, 2, 3. When we have our vertical asymptote there, we have a vertical stretch. So instead of being just 1 spot away, it's going to be 2. So we're down to here. Right. And again, we want to get incredibly close to this asymptote, but not actually touch the asymptote. And so then there's your picture of the rational 2 over x plus 3. All right. Negative x plus 3, there's your absolute value going down up 3. 1, 2, 3, and we're only going from negative 3 to positive 3. So because we go down, it would look like that. So it's that V going down. But over here at negative 3, it should be an open circle. And there's your absolute value. Good, that just leaves us our log picture. Now remember, with our log, that's the one that starts at 1, 0, 2, 1, because it's a base 2, 2, 1, and then 4, 2. So you would be here, okay, and then, oh, sorry, with the minus 3, that means you move right 3, 1, 2, 3, so actually 1, 0 is here, 2, 1's here, 3, 4, 2 is here, so disregard that point. And we are going to go 1/2, 1/4. So our log picture would go like that. Okay. So as we go across, starting with our domain, arrow to arrow, but notice we do not equal at negative 3, so we would have to be able to say negative infinity, negative 3, union 3 to infinity. X is all real numbers, but x does not equal negative 3. So interval notation, set notation, your choice. Okay. For your range, we have a negative arrow here, we have a positive arrow here, everything else in between is covered, so this is a all real numbers. And then the last piece is you're just identifying the two y values. So when x is 3, notice we go by the closed circle, so we have a y value of 0. When x is 4, again, closed circle, y value of 0. Don't have to plug it into the constraints to plug it in and simplify. And again, short, basic, comprehensive piecewise functions. Can you do domain? Can you do range? Can you identify y values? That is it. Thank you very much. Bye.